Okay, in this video I'm going to show you how to make paper aircraft that you can do aeronautical investigations on. There's things you can adjust and tweak and do some actual science. I pinched the idea from these aircraft from this website, and I'll show you that URL again at the end of the video. To make these aircraft you need a sheet of A4 paper. So I've got this stuff with a print on one side so you can see what I'm doing. We're also going to break some rules of origami, so you're going to need some scissors, a stapler. I'm going to need some pliers because this paper that I'm using is very thick and I need that. And actually, if you've got one, a tape measure is useful too. Right, to make the aircraft, the first thing that you do is fold your sheet of A4 paper into A5 like this. And you need to make sure that you've got crisp, sharp creases, so I'm squashing with my thumbnail, and nicely matched corners really matters as well. So those origami ideas apply, and it's worth putting a bit of effort in to get a repeatable aircraft. When you've got this A5 size, you need to take a loose corner like this one and fold it down to make a 45-degree triangle. So I'm folding it down to that first fold there, and like that. And these aircraft are symmetrical, so whatever you do to one side of the paper, you need to do to the other side here. So this corner down to that first fold, and squash those creases nice and sharp. The next step is the one that goes wrong most often if I do this with a class of people. So make sure you get the right edge. So I've got rectangle, triangle, boundary between the two, and this edge here I'm going to fold up to the hypotenuse of this triangle. So I should go like that and get a little isosceles triangle down at the bottom here. Okay, and sharp creases, flip it over, same again on this side, rectangle, triangle, join between the two, fold it up to the hypotenuse. And little 45-degree triangle down at the bottom there. Right, it's a very thick paper that I use, but I like the design, so there we go. Right, the next thing is I'm going to flatten this whole thing out and start to break the rules of origami. And the first rule I'm going to break is scissors. I'm going to cut this shape from this corner here up to this point here where these folds meet, and I'm going to cut along this first fold that I made. So start here, cut along the fold until I get to just there where that fold meets, just there, and fold it back like this, back together again. And the next fold that I'm going to make I couldn't make unless I'd made that cut. So I've got here a triangle, a white triangle, and I'm going to sort of fold that triangle in half. So this edge here I'm going to fold up to meet this edge here. So it's quite easier with thin paper to do this, but it doesn't show what I'm doing quite so nicely. So there we go. Fold that like that, and I've done that the wrong way round. Fold that like that. That's what I'm aiming for. So I'm folding it back, and you can see these narwhals poking themselves out. Turn it over, and it's that same fold again. So halfway down this white triangle, but I want this tip here to end up below my original fold. So fold that in half, like that. Squash that down. And then The next fold that you do is sort of the same again. There's an edge along here with a stack of folds, and this piece here, I can fold it because of the cut. I can fold it back along that edge, and same again here, and I end up with this shape. And this is the first bit that you can exercise lots of design control over. The next step is to cut a wing shape out of this flap of card here. There is one constraint. This edge along here is what holds the whole thing together. So leave a chunk of material here just to stick it together. But then you can cut whatever shape you like. And if you want to be really careful and do a proper piece of science, you could make this out of graph paper and go investigating things like the effects of area on wings. I'm just going to cut a nice shape. I think I aim to produce a sort of shape that looks a bit like mosquito insect wing here, but any shape that looks wingy will do. This bit's rubbish, don't need it anymore. The next part of building, because we haven't quite finished, is just here. There's two little flappy triangles that are just 2 layers of paper thick, and you can fold those up to this bulkier edge here, and the same again on this side. And when you've done those 2 folds, you can make this aircraft sit flat on your bench. And then next origami rule breaking is a staple, and you want to make this staple as symmetrical as possible about this centre fold here, the first fold you ever did. I've got really thick paper, but I have to really press hard to get that staple through, and actually for me it pays to have a pair of pliers just to squash the ends in and make sure it grips properly. So I'll do. Right, that is the construction of the aircraft finished, but there are bits and pieces you can do to play with it and make it fly better. There's a video link, a YouTube video link that I'll show you at the end of this video that talks about how wings work, and it uses the idea of curved surfaces and curved air. And these spars at the leading edge here are actually quite flat when you finish making the aircraft, but you can squash them and make them much more tubular and round. And I reckon you could measure this thickness here and measure how round you've made them and see what effect that has if you make a succession of these aircraft. Another thing that you can do to add more curvature is tuck your thumbs under here and have a go at stretching the paper and putting some curvature in that way. So loft this up a bit and try and make it curved. And the final trick that you can do to make these aircraft fly better is you've got a staple in the middle here, and you can bend it and put quite a hefty V on these aircraft. The technical term for V wings is a dihedral, and dihedrals work to make aircraft stable. So you get most lift from horizontal wings, but quite a few birds and quite a few aircraft sacrifice a bit of lift for stability. And the reason they do it is this: if you imagine this aircraft flying into the table away from the camera, if it starts to roll like this, this wing is now more horizontal than this. So this wing has more lift, this one has less lift, and so it's going to tend to turn back to a horizontal position. Same this way, more lift here, less lift here, tends to self-correct. And that's so useful. Pigeons have really dihedral wings. Next time you look at a pigeon in flight, very, very V-shaped wings. Launching these aircraft, like all paper aircraft, you have to launch them at glide speed, and these aircraft have quite a low glide speed. A lot of people are used to making darts, So those are the aircraft where you take a sheet of A4 paper, fold it in half lengthways, and then lots and lots of triangles, and you make a long, thin delta wing aircraft. They have a high glide speed, which is great. You can give them a good lob and they will fly nicely. These are more subtle beasts. You have to launch them very gently because they have a low glide speed. So the way I launch them is finger on top, thumb underneath, the rest of my fingers out of the way, and you sort of waft them out onto the air. If they stall, which means they fly and then shoot up shortly after launch, you've launched them too fast. So have another go, practice, and you will suss out how to launch them nice and gently, but that kind of flight is what you're aiming for. That's the URL for where the design comes from. This is the chap that designed it. If you want to know about how wings work, then head to youtube.com and put in this phrase, wing lift by Holger Babinski, and you will find a video on how wings work. If you want to go doing science investigations with these aircraft, you have to do a lot of repeats of each set of conditions because it's very hard to get exactly the same launch force every time. And if you could invent an automatic launcher for them so to make your experiments more repeatable, that would be pretty nifty. But the thing to go measuring is you will need a long tape measure, or a succession of tape measures end to end, but one long one's best. And what you go measuring is the glide ratio. And the glide ratio is the ratio, there's your aircraft, and that's the height you launch it from. So this is launch height. And you measure that, and you measure your glide distance. And the interesting thing, the glide ratio is the distance travelled divided by the launch height, and that one is the measure for the factor that you're altering each time. So area, tube fatness, I don't know what that's called. Whatever factor it is that you're investigating, what you're looking for is its impact on glide ratio. So that's how you calculate it. Lots of measurements, plenty of repeats. It's hard to be consistent with this experiment. But thank you for watching. Enjoy making videos, making aeroplanes.